Hi everyone, welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. We have weekly events, and today is one of such events. Today we actually have two events, and there is more of the events, so we have quite a bunch of them. So there is a link in the description, so if you go there, click on that link, you'll see all the events we have in our pipeline. So check it out. Today we have also quite an interesting workshop about using Terraform and ClickHouse. So yeah, check it out. Then do not forget to subscribe to our YouTube channel. This way you will not miss out amazing streams like the one we have today. And finally, we have an amazing Slack community where you can hang out with other data enthusiasts. And I think I say amazing too many times. I need to work on that intro. Anyways, so during the interview, you can ask any question you want. There is a link pinned in the live chat. Click on that link, ask your question, and we will be covering these questions during the interview. Now I will stop sharing my screen. I will open the document with questions. It's Atita, right? The name?
That's correct.
It's always difficult with such an international community. You never know how to pronounce the name correctly, where to put the emphasis. So it's Atita, right?
That is correct.
Hopefully I should to say it correctly in just 1 second. Okay. So I'm ready. If you're ready, we can start.
Yep, I'm good.
This week we'll talk about search, and we have a very special guest today, Atita. Atita is an expert in information retrieval, also known as search. She has contributed to projects like Apache on OpenNLP, and she advocates for user-centric approaches. She's very passionate about promoting diversity in tech through groups like Women of Search, and currently she's researching RAGs. We'll talk about what it is, for those who don't know what this is abbreviation, not like RAGs. Welcome to the interview.
Thank you.
Yeah. So the questions for today's interview are prepared by Johanna Bayer. Thanks, Johanna, for your help. And let's start. Before we go into our main topic of search, let's start with your background. Can you tell us about your career journey so far?
For sure. So thanks for having me. I think I would definitely like to say at least one line before we begin that I've always, followed DataTalks.Club since I think very beginning. I think it's an honor to be here on the live interview. Definitely the first for myself. And because we were talking about my name earlier, I think that's where I'm going to start. So I'm not sure if a lot of people have already noticed that my name is actually a palindrome, name as well as my last name. It's a palindrome. And both of them, yes.
Is it a coincidence?
I think it was a pure coincidence because I definitely checked with my mom and she told me that it wasn't really intended the way. And it's also very surprising that my name, that the meaning is, it's a Hindi-driven name because I come from India. And it is derived from the word Atit, which means past. So anything or the events that are driven by the past events. And I think our listeners would be very, very smart enough if they can, guess that what exactly is driven by the past events, because that's probably what my mainstream job is as well, like a machine learning model, because it uses the past data to predict the future events. So I think it's a mere coincidence that my name definitely falls into the similar stream as of my career. And I'm pretty thankful to my parents as well for naming me this way. So that was a short background of my name. And I hope we can now say it correctly. It's Atita Arora. And I have no connection with the Northern Lights, just to clarify. Yeah. About my
Aurora, right?
Yeah, yeah.
Aurora Borealis.
Yeah, that's correct. So a lot of people think that my first name is Aurora because that's definitely the case in Europe. But my first name is Atita. Aurora is my last name. So about the career journey, as obviously you already have in the introduction. So yes, I started in 2008. It's been 15 years. And if we count like the time before my master's, it would be actually 2007. And I would say that now I'm feeling fortunate that I started very early on with the information retrieval space, pretty early on in my career. But at that point in time, like as an early 20s person, definitely wasn't too happy with like, why am I, pushed into this field? Because I was campus hired by this company, which was really big into like working on the revolutionary products, and it was set up by a Stanford professor. So I think I was feeling lucky that, he chose me out of like the batch of 96 folks. So, but when I joined the company, that the first thing that they asked me to do was like, we want to work on detecting the relationships between two entities. So I obviously realized, in the course of the journey of my career that it's called semantic web. So I started working on it in 2007. Definitely a lot of people did not know about it. And the application that I started working on was based on Solr and Lucene. So Solr was pretty early on in like the version 1.2 back then, and there was no Elasticsearch. People were still struggling to move from databases to Solr, and they were really pounding on like why they need to move away from database and what is there not present in databases and why they need to have a full text search engine. So I was born, or my career was born between that struggle, and while lots of my friends, working on Java J2E applications and .NET, I was battling with this beast called, semantic web. So definitely not a very pleasant time, to be honest. But now I feel good that it happened to me very early on.
Because it got traction later, right? Like
exactly.
I remember already, like 2015, companies were using Elasticsearch, Solr. It was already
Correct.
like, yeah.
Correct. Even big data didn't really have the name big data back then. I mean, when I was working on, I think only until 2012 is when I really understood that, oh, this is exactly what I do. I mean, is it called like big data? Okay, that's kind of interesting. So yeah, I think in India as well, I think we don't really get a lot of traction as well. Probably if I was in one of the Western countries, US or Europe back then, probably I would have been able to, work on it more. So yes, I think this was the initial part of the journey. And I think back in 2010, 11 is when I was approached by this training company that works the similar way as the Coursera works. And they asked me to develop the course on Solr. So I think it was happening more and more, but it kind of, sidelined. I also got to work on a lot of, content management systems, because search is a very kind of backbone functionality of any content management system. I mean, definitely people can put on the content, but the major, kind of challenge is finding the right content. So this was where I also realized that, like matching what the person needs, like how to match right content with right person. And it just grew more and more in as I progressed in my career. So I think this definitely kind of, tricked my brain a lot more than that. And that's when NLP happened. So I understood that, natural language definitely has a lot of prospect. So about in 2012-ish is when I was first, using the NLP in my project. And I was very surprised.
What do you mean by NLP? Because I remember, so for me, NLP started also with search. So there is this book, Introduction to Information Retrieval. I think one of the authors is Manning, right? Mm-hmm. That's the last name.
Yeah.
And the book was very nice to read. And then I was recommending this book to anyone who was interested in NLP as a good introduction to NLP.
Right.
So that's why I'm wondering. So to me, kind of NLP and information retrieval always came together.
Right. I think as of now, I would say that it definitely is like interchangeable sort of a term. But I think search in principle, because as I said, that people were moving from database to a full text search engine, people were still kind of, hung up in that token search mode. So it was really hard. I mean, people didn't really realize that they could actually have more than one phrase and they could still have search results. So I think this is what, natural language processing kind of enabled. And we realized that with the content management system, it became even more and more, important, because people wanted to be sometimes, like describe the kind of document that they were looking for, sometimes with the content, sometimes with a title. So it definitely boiled down to how do we match right content with the right query. So I think this is kind of where it went into, and my curiosity into definitely the other factors as to, for example, what kind of query should match what kind of content based on different kind of business KPIs. So definitely there were a lot of, other factors which came into the equation now. So that drove me towards going for my second master's in strategic business management. And I wanted to understand more about like how are these business components deducted. So I think this got really interesting because I never took up management as my first career, because I was very attached to technology. I wanted to make things by myself, and I think that was very interesting for me. So moving on, I think I would be kind of like not overbearing if I say that I got a chance to work with all my dream companies. I worked with Lucidworks, which was pioneer in the search consulting, and then also OpenSource Connections 2 years ago. This is when I realized that search quality has more than like matching right content with right user and providing a measurable aspect behind it as well. So it was definitely
companies. Yeah, sorry for interrupting you, because like I really want to ask you
sure.
about Lucidworks and OpenSource Connections, because these two companies, like for everyone who works with search, they know these names. And yeah, especially like if you go to conferences like Berlin Buzzwords, you usually see a stand from Lucidworks. So they're quite present.
For sure. They have their own conference, Solar Lucene Revolution, as well, which was later called Activate when AI became really a thing. So I've attended those as well as an employee.
Yeah, so I'm just wondering, like, how did you manage to get into these companies? Is it because you, like, did you need to do anything special, or it was kind of obvious and they said, okay, like, we see that you've been doing search for so much time, like, come to us, work?
Oh, it wasn't that simple, actually. I mean, if I talk about from for Lucidworks, actually one of the support engineers was in my class, the course that I mentioned, that the one that I designed and delivered for almost 2.5 years. So he was in my class and he reached out to me that, I've joined this company and I feel like you would be a great fit because the way you describe things, it would be amazing for our clients to know how things are really happening in the background. It was a pretty long process, to be honest. It was like 8 long meetings and they grilled me on every different aspect of Solar and Lucene in terms of performance and like the application level and everything. And then finally I got in. It definitely was a very accomplishing feeling.
So just having the credentials of teaching a course is not enough, because they really want to test that
Oh, yes.
ins and outs.
Yes. Absolutely.
Because like they're consultants, right? So they need to make sure that you do that. Okay.
Right.
But like from what you said, it's very helpful to teach courses because your students eventually join companies, and then they always remember the teachers, and they can.
And I would be candid to tell you that when I started teaching the first course in 2013 or 14, if I remember correctly. I mean, I started in 2008, and when I was teaching in 2014, it was really hard because there were people in my class who were like pioneers of Java applications, and they were asking me really low-level questions about, okay, so you're describing faceting, like how exactly would it work? I mean, can you tell me like the low level of how faceting really works, like in a disk or in RAM? And what exactly do you mean by doc values, for example? So it's a columnar index, is something that I cannot get away with. So they used to grill me, and I used to really feel like, oh my God, this is like really taking my all my energy. And I used to prepare for almost like 2-3 days before for that 3-hour class on a weekend. So definitely, I think that really pushed me going too far with what really needed. And I was digging into the resources and definitely using Lucidworks for a lot of my content preparation, because at that point in time, there was no Stack Overflow or popularity of such searches and, like the reading material. So I was always looking up to Lucidworks for, different content. And I was like, how is it like, if I could work with such an organization? So that definitely had my, all my dreams and kind of expectations that I would work with this company. So definitely a very accomplishing moment. And I think the similar is for the open source connections as well. Because when I moved on, I realized that maybe achieving good search isn't enough unless you can explain what is the good. I mean, you need to describe good in the parameters of the KPIs, the business KPIs. And I think that's what I got to know from open source connections. And I think I also got brilliant opportunity to contribute on a lot of open source tools and projects. So I've been contributed on most of their projects that they have. And they're very welcoming as well. And I think the very structured approach to, address the relevancy and the search quality aspect of the search. So I think that they are the people who coined the term relevancy and the relevancy engineers. And they have a lot of courses and a lot of content around it. So again, great blog post. And I've been contributed on that too. So definitely. And I think I am taking that legacy that I learned, all of that from them. And I'm trying to apply some of that as well to my new company. So I've started working with Qdrant recently as a dev relations manager. And hopefully that I could benefit all my learnings in my new role. And because we're on the topic of also search, I think one thing that stood out to me on Qdrant is that if I have an existing search engine, I mean, I could still, experiment with vectors. Definitely, I always say this out beforehand, that don't be smitten by stuff because it looks cool. It has to be very much, like implied by your use case. So everyone doesn't need vector, definitely. And you need to have definitely some sort of, investigation into if your use case is fit for vectors. So if yes, then...
And Qdrant is a vector database, right?
Yes, that's a vector database or vector search engine, if we can say. So I think in the word of everything being SaaS-based, I think it's pretty a decent, proposition to go for. They're pretty amazing because I also worked on Rust in 2017. So have basic, lot of trust in Rust. It kind of rhymes.
It's written in Rust, right?
That's correct. Yes.
Yeah. So we had a demo from Casper. I think he is still at Qdrant, right?
Yes, that's correct.
So he gave a demo maybe a year ago. And then I asked him, okay, it's like Elasticsearch, but for vectors. And then, yeah, and we're written in Rust.
I would agree. Actually, that was also my first kind of, like the occurrence when I started using Qdrant. That it's, I mean, the APIs and the console is very driven by Elasticsearch. I'll be honest. I mean, if people love Elasticsearch, they would definitely love Qdrant. Only that it's more scalable. And because I have been always, the advocate of open source. So, I mean, all my previous projects, be it Solar, Lucene, Elasticsearch, or OpenSearch even, because that was the last projects that I was working on. I mean, I've been the advocate of open source. And sometimes, because we used to work with the clients, people used to be confused as to, if I should be using vectors inside Solar, because I think if we talk about putting vectors in your existing system, definitely it comes along with a lot of pain in terms of, having to make changes into your config and then, iterations for ingesting your index items. And then obviously configuring like a wraparound how these, results would be served. Definitely, it all starts with like, what exactly do you want to achieve with vectors? So if that is what you want to do, I would recommend that you should check out, Qdrant, because you don't need to touch your existing search engine because it can stand parallel to any existing search engine. And it can natively provide, first-hand support for vectors only. So, and then the nature of being scalable and very kind of, plug and play sort of way of vectors, it doesn't really ask you to bring your text search into the stack, which is like, you can keep using your text search, whichever stack you prefer. And for vectors, use Qdrant in the parallel. So that's definitely like one of the perks that I feel like your existing application isn't really disturbed. You don't need to process everything else. And you can already kind of bifurcate from your messaging queue and put your vectors into Qdrant. So
I'm just wondering, so like I know that there is support for vector search in Postgres, for example, then there is support for vector search in Elasticsearch.
Oh yeah, also Solr, also OpenSearch, yes.
Solr,
all
yeah,
of them have
like
the support for vectors now.
support that, and then
Correct,
automatically,
correct.
like,
it fans out to all the products that use Lucene.
And and then at the end you can also have a standalone vector database.
Exactly.
So when should we, like, let's say we already have an existing Solr installation, which supports, hopefully it's one of the latest versions and it supports vector search. So when do we need to go with Solr or Elasticsearch, or when do we need to look for a standalone database?
So I think that's a good question. And I think because I've given several talks about, using vectors inside Solr Elasticsearch before. And I mean, OpenSearch also supports natively vectors as well. So that talk was basically oriented behind like people need to dump their existing systems and, move to one of these vector search engines or vector databases. So that was not really the case. I mean, if your case is something like, for example, if you can afford to have reindexing, if you, because I've worked in some of the projects where reindexing is not really an option. Like there are businesses who cannot really reindex their data set. And I think this is a very classic use case where you could use Qdrant because you're not really kind of, disturbing anything that's up and running. There would be no downtime for the customers, the existing customers. They can still keep on using your existing sort of solution. Whereas for the experimentation with vectors and trying to figure out if that is what is going to work for your solution, you need vectors. And I think this is where Qdrant kind of comes into the picture. And I think there's a new blog post released today. I think Andre probably posted that on LinkedIn. I think it's a very sort of apt description about when would Qdrant kind of comes into the picture and when it is not relevant. So definitely, like if you're looking for ease of operations and you cannot reindex, I think Qdrant is one of the solutions to go for, because I mean, I loved it that they're not even pushing customers to like, we can do text search for you. We can do this for you. We can, train models for you, or we can do N number of things for you. We just do vectors. The very focused, and in my understanding, when you're focused on one thing, because I have been focused on one thing for the last 15 years, I would say you turn out really good. Because you're not really distracted by so many different things. You're not distracted by, supporting multiple languages, text search, or so on and so forth. So I would say like that's definitely worth to try.
So as somebody who has worked for 15 years in this area, you probably started with, I don't know, creating indices for Lucene in something similar to MapReduce without Hadoop being there. And now it has changed significantly since then. So now we talk about LLMs, vector databases. And I'm just wondering, like, for you in these 15 years, what were the major things that happened that you saw?
A lot. I mean, it feels sometimes nostalgic. Sometimes if I look back at the stuff that I did at my first company, it feels like I probably did that in my previous life because it's so different now. Because initially my challenge was I was working with Solr 1.2 and Lucene 1.7, I think. They both were different packages. So making sure like they work together, it was heck of a thing, because it literally like trained me out that how do I make, what kind of configuration would I put in that these two start talking to each other and doing the stuff that I really need to do. And from there on they became like one project in GitHub, and now they're separate again. And from the feature point of view, if we would see, like after the introduction of more of natural language processing application features, definitely the focus was more on understanding the queries, and then synonyms and stemming and lemmatization. And then promoted searches, all of these, came into the picture as well later, part of the kind of era.
Mhm.
And then personalization was definitely like another thing. So initially the personalization was limited to like, configured searches or configured brand. Inside the configuration, they were very still stagnant, not changing unless someone changes them. From there on, people wanted, them to be changing every week or based on the customer demand, based on what's popular, so popularity index. So things were becoming more kind of, measure and then apply them into your searches driven. And then personalization became from like, oh, what two items were like kind of, sold together. We have to promote this brand. We have to have like recommendations, which are like, if this person is interested in this product, what is it that we should recommend? More of obviously machine learning came into the picture, then learning to rank became a thing. So the ranking and sorting kind of got affected with that. And now we see that it's all about large language models. And definitely, I mean, if I was to say, I mean, we're definitely moving towards more and more rich features with every passing day. And now that ChatGPT, which obviously turned 1 year old now, I think things have changed even further, because everyone wants a chatbot or a search bot on their business. Like, people don't want to be limited to token-based searches anymore. People are not satisfied with the synonyms or rules or search management per se. People want more. People want their search engine to talk like ChatGPT and action-based, and then so many other things. I mean, I don't know. I hope I was able to answer that, cover some of the things. I might have missed.
Very difficult to kind of squeeze 15 years into like 5 minutes, right?
Yeah, that's
but also
true.
like I remember, so when Word2Vec appeared, I was at university, and everyone was like, "Oh, have you seen that? Like, king minus what was that? King minus one plus woman is queen."
Oh, yeah. Oh, that's a very classic example. Yes,
Yeah.
it's like one of the examples which I saw in almost all the presentations that I saw.
Yeah.
And even now, I think I saw very latest, I think, presentation, which
But
was
back then, like, okay, you have this bunch of vectors, and then you have this GenSim implementation, right?
right,
Like, how do you keep these vectors? How do you use it? And then, like, we
right.
would implement locality-sensitive hashing or locality LSH,
But
right?
vectors, in principle, like if you look at, I mean, it's not something that appeared out of thin air recently. I mean, it's been a thing since 1970s. And if
Like,
you look
they
at
burned the databases, right? So now it's so difficult to choose a database. Back then, like, you would, okay, I have vectors. What do you do with them now?
yeah, right, exactly.
But yeah,
No, but
I think they were around for quite some time, right? Like,
yeah, they've been around like since, I mean, I would say they're older than me, if I was to say. I mean, the concept is older than me. And I think maybe the limitation in terms of the infra was one of the things that kind of held them back. And now that we don't have any limitations in terms of, infrastructure, we have GPUs and whatnot. So I think that has basically made them fast enough that they can be used in production today. So that's definitely like something that has enabled it. So, but the concept has been around. And if you look at the inverted index is also a kind of vectors. It's just that it's in the manner of zeros and ones. So a sparse index is also a kind of, vector index. It's just that the dimensions are going to be dictated by the number of tokens in your index, but it's obviously kind of a vector. So I mean, if you look at it, that's one way to kind of picturize. I mean, I'm very photographic in terms of my imagination, so it was easier for me to think of like, okay, it's not a new thing that I'm doing. It's just that we're putting kind of more emphasis on the vectors being generated through another model that has the understanding of these tokens and how the context of these tokens together would dictate into a pattern or a vector.
Yeah, my master thesis was about search too, and I
Mhm.
remember reading this paper about vector spaces, which was from 70s, I think,
Correct. Yeah.
if not earlier. I think it was 70s, right? And
Yeah.
then there
Yeah.
was another paper from 90s, from 1990,
Mhm.
about applying SVD to.
Correct. Yes. Yes. Absolutely. So I have also linked some of these papers to my presentations. So yeah, I was also pretty researchy about how did this come into like existence and what was the early on research about it, because definitely I was trying to put on my data scientist or kind of researchy hat on, like what more can I find out about it. So I mean,
Yeah,
I would
it's been a
agree,
while.
I would concur. Yeah.
Mhm. But now we have these things like RAGs that I mentioned at the beginning when I was reading your bio.
Mhm.
Maybe you can tell us what is what is RAG? What is it? Like, why
So
do we care
RAG,
about
yeah, RAG is the abbreviated form of, so RAG stands for Retrieval-Augmented Generation. And as the name suggests, obviously there are two important pieces in here, retrieval and generation. So what we tried to do, and as part of like my previous project with the open source connections, we were working with a client with, applying a retrieval augmented generation in production for one of a very big research companies. And the basic idea is, because I said before that everyone wants like a chat GPT kind of an assistant on their website now. So retrieval augmented generation kind of enables it. So what it does is that obviously, if you're using plain LLMs in your search, imagine like your question being sent to LLM, which has very limited knowledge based on the data it was trained on. It would respond, and sometimes you would see that the responses are not correct. So it would make up things, and these are generally termed as hallucinations. Or I would say, like in a more black and white term, that this response is not correct. There are no basis to kind of justify that this response was correct. So that's when the augmentation of your data with the existing LLM kind of took birth. So what we do is that when we are sending the query to the LLM, we provide the context with the client data. So this was the augmentation of the context of the data. And this helps basically the large language model, or for example, the OpenAI model, to have a context of this is the question being asked, and this is the context I need to answer this question on. And there are less chances of the answer being a hallucinated answer.
Mm-hmm.
So that is what I was working on. One of the things, because I've had the background of machine learning as well, is that, and we have measured everything. And I think, in my opinion, and this is kind of something that also, business folks need, is that if there's something that you have worked on and cannot be measured, I mean, it doesn't kind of, fits together. I mean, you need to define the good. So the good in this case was really hard. The evaluation of such systems are really hard because of the nature of the problem. And we need to have evaluation to justify so many different things, like a go, no-go decision, because there is the reputation of the company at stake. There's the effort of the team at stake, and we don't want to spoil all of that. So we definitely need to have the evaluation to make sure that whatever we are shipping out is worth shipping out. So definitely that part evaluation kind of covers. And we also need to evaluate things based on the business KPIs, because now that we have access to KPIs, the key performance indicators, we need to see that if it matches with the business kind of matrix as well. So the evaluation of such system kind of becomes really hard, because the main, I would say, the underlying feature of LLMs is the diversity of the responses. So it's not simple as like the search evaluation, because we don't know what it would respond. So in case of, for example, one thing that I did not, or probably forgot to mention, is that out of these 15 years, I've given that to e-commerce search, because that's where a lot of implementations and projects were coming up. So I've had very rich e-commerce experience, and things are also I somehow love e-commerce because the results are fast. You see the response, and you see the kind of customer adaptability to the new features very quickly, and it somehow is very driven by if certain query needs what kind of response. So what I was trying to say earlier was that in case of, for example, e-commerce, we have a very clear structure in terms of this is the query, this is the response, or this is the response document, and this is how much this is relevant. So we had access to the trios, for example. So we knew that this query would give certain number of answers. There was concept around precision and recall, but RAG is much more complicated because LLM itself, need to give you diverse responses like a human being. So if you ask a question from a human being, there's a good chance that it would respond back in a different words or in different, way to the questions. So this is what we wanted kind of with LLMs as well. And if something is not responding with fixed set of...
Yeah, I would just want to try to summarize what RAG is before we go into relation. This is an interesting topic. So let's say we have a podcast, right? So there are 16 seasons, 9 episodes in each. It's quite a lot of information, right? And for each podcast, we have a transcript. And let's say if we want to build a chat application based on top of these transcripts. Right. So we have in Slack, we have a lot of questions about career and other things. And I'm sure for like 90% of questions, 95% of questions, there is answer somewhere from one of the guests. Right? And then it would be cool to build. It's actually a nice idea. Maybe we should do
I think this is what I actually built. I mean, oh my God, I actually never open sourced it. I open sourced a very small RAG demo. But yeah, I think I am cooking definitely something up, which would be about RAG evaluations and also, RAG application. Hopefully you could use that. So yes, that also involved the Whisper from OpenAI, because that also involved podcast, just so. Not spilling beans about it, but yes, I mean, I was using transcript and storing the vectors of this podcast transcript into the vector database. But the point being that, again,
I'm just curious, like with the podcast, right? So we can do it, and then we can build a chatbot based on top of that, right? But the problem with OpenAI, it has no idea about this podcast. Hopefully it has, but like if you ask a specific thing, like I know about search, it might reply, but not necessarily with the information I want. So I want to use, for example, our conversation right now. Right. But it might just come up with some answer, and we don't know if this answer is good, right?
And it's also timed. It's also timed. Like it is timed for the time when it was trained. So there is a block. There is a cutoff for the information. So it doesn't know about any recent events. So for example, earlier we used to see with OpenAI that my response set is limited until I think June 2021, something of that sort. So anything that must have happened after it has to be explicitly provided. But if you provide that to OpenAI or the ChatGPT, for example, it gives marvelous responses.
So we need to find a way to provide, actually, to tell ChatGPT or GPT-3, 4, whatever, that, look, we have these podcast transcripts, and this is the question from the user. How can we use the transcripts to answer the question? And then our goal becomes, the problem we solve is like, from all these transcripts, and from like each transcript has like, I don't know, 50 minutes of stuff there. Like, how do we actually find the right thing? Like, how do we find the answer to this question in this database? And the answer is we somehow vectorize them, right? And this is
so I think that's what so that's what I also figured out, that there are different kind of I mean, I kind of prepared and I wanted to save it for my blog though, but it's kind of 4 levels of the evaluation, for example, we need in the RAG evaluation. So what happens is, obviously depends on the model that you're using. So model has to be driven by, for example, how general it should be or how domain specific it should be. The second being obviously on how the data has been ingested. There are several different, statistics around it. For example, how have you prepared the vectors for the podcast, for example? So what is the chunk length?
How would we go about preparing it?
So
like you can ingest the entire article, right? Or you can just ingest every sentence, or you can go with paragraphs. Like how do you select?
Correct. So depends on, like, again, the user experience. So what you want to deliver. So if you don't want the user to be redirected to like, oh, this is the podcast where you would find the answer. That's definitely not the approach that, businesses want. They want exact thing to be given to the user, that this is where your answer is, like a very specific answer. This is where chunking comes into the picture. So which is why you need to invest a little bit effort into how you ingest these podcast transcript. This is where it comes into the picture, like the model that you've used, what is the context length or the token length it supports. So definitely we need to also provide, like, when we're going to chunk the entire podcast transcript, like how much overlap should it have? Because, for example, I may be referring to a lot of things that I might have introduced initially as bold, and then I would be referring to it, them, they, and obviously LLM would not really know, like, what exactly is it? What exactly is they? What is them? So definitely the overlap is of very, very big importance in that case. And how much overlap does it need? We need to have an experimentation platform for that. Similarly, we need to have like chunking strategy. Some of that obviously LangChain has enabled. So a small kind of demo chatbot you can build with LangChain. People have been discussing that all over LinkedIn if LangChain is kind of production ready though.
What's LangChain?
Oh, LangChain is, that's kind of interesting question. I'm not sure if you've not seen it, but LangChain, you've heard the name.
Somebody hasn't.
Oh, okay. So, I would say, like, from my limited view, and that's what I've used LangChain for, is that it provides you with the different connectors in which your information can be retrieved or information can be absorbed from your, vector database or your search engine, for example. And then it also kind of, sits between your retrieval and your generation kind of, stages in the architecture.
So retrieval is when we ask the bot something and then it needs to find the answer. So this is the retrieval part, right?
So retrieval part is more like, so for example, if you visualize there is a query and there is a search engine in between.
Query is what we put in the chatbot.
Yeah, that's the question. Right? That's the question, yes.
For example, I am a product analyst and I want to become a data scientist. What should I do, right? That's the query. That's the question that the user puts in the chatbot.
Correct. And then
next with this.
So what happens next is, obviously, this query would either go directly against a language model, or in our case, we would want this query to be sent to the our vector search engine. So this definitely, what this would do is that your query is going to be converted into vector, and your entire query is going to be converted into a vector search query. And this is going to be sent to the vector search engine of your choice. So this vector database would have the chunks based on the chunk strategy, based on the length of the chunks that you've used, based on how much of the overlap do you need, how many chunks do you want to retrieve, based on the number of responses you want to have. So as you can see that, like, there are a lot of, different things that you can experiment. So we, as of now, assume that we know whatever we want in this case, and we retrieve maybe, for example, say 5 chunks, 5 relevant pieces of information that would help ChatGPT to answer these questions. So what we do is, then comes our prompt, the prompt that basically is sent to the OpenAI, that you are probably a research analyst or research assistant, and this is your context, and this is your query. Now, can you answer this question? And then you can define as many guardrails. Like, if you don't know the answer, please don't blabber, please don't hallucinate. Don't just say that I don't know. I need more context to answer this question. And then you basically process an answer, a relevant answer, which is prepared by summarization of these chunks and is given to the end user. So obviously you can also provide maybe, or you can spice it up by providing references to the related documents where this answer was prepared from, which is kind of, addressing to the explainability of the response, so that there's something like, for example, people want that the AI responses should be explainable. So by attaching the resources, we could always, say that this is where the relevant information would be found. So there would be some sort of like trust from the user that is built into the system in that case. But as I was saying, evaluating such response is very kind of difficult because a user could have several different questions. It could be about a particular domain. It could not be about particular domain. And obviously, we are not blessed that we would have, access to like the golden set or the judgment data. And this is where the evaluation kind of, becomes really important. Like we need to break it down into multiple, layers of evaluation. So you could individually evaluate the model that you're using to generate the embeddings that go into the vector database. You could individually evaluate the chunking strategy and all the factors that are related to how the content is going to be split. And then you can also evaluate like the retrieval strategy, like if 4 chunks are enough or 5 chunks are enough, or we need 10 because the responses are mostly from the assistant as like, I don't know, I need more context. So that all kind of, drives us into a more metric-driven system. And then obviously we can have, end-to-end evaluation as well, if the responses were correct or not, maybe using something like NPS, Net Promoter Score, thumbs up or thumbs down, which could be used to broadly identify if the system is addressing its purpose. If you address and answer questions from the users. So thumbs up stands for like, I was happy with the answer. Thumbs up, I was not happy with the answer. There are, again, ways in which we would want it to be adapted into a pipeline, like a chatbot pipeline, or we could also do it in an offline way. So I think my blog is probably going to cover both of these strategies.
I'm looking forward to that.
So sure.
I just want to again go back to the example about a chatbot or the podcast. So let's say we built that. So we somehow split the article into chunks. Then we ingest each chunk. We create a vector for this chunk. We store it in a database, Qdrant, for example. And then the user comes with a question. Then we turn this question again into a vector. And then we use the vector, the query, to query the database, right?
Correct.
Then comes the retrieval part. This is a vector query. Then there's the vector database.
We're going to retrieve the content, yes. Based on the vector similarity, we are going to retrieve the content part, and this populates the context of the prompt.
So we include this in the prompt. So
Yes.
I am a data analyst. I want to become a data scientist. And then this is a question, and then answer this question using these chunks of.
Yeah, based on this context, yes.
So that's the augmentation part, right? So first the retrieval, we retrieve it from the database, then we augment our prompt. And generation is we send the entire thing to the LLM, and then it generates the answer.
Right, that's correct.
And then you were talking about evaluation, because like right now I have this RAG system with all the podcast transcripts, but now I want to see like if it's working fine. I can of course go ahead and test it, do like 3, 4, 5 queries, and then see, okay, like it kind of makes sense. But then there are so many moving parts, right? So
I
can use different chunking strategies. I can use different LLMs. I can use different databases, right? So the number of like the amount of combinations of these parameters is just insane, right? But I need to somehow come up with an okay thing that works, right?
Yep.
And then here we were talking about 4 levels of evaluation, like at each level. But like for me, like for example, if I want to build the same thing, what's the easiest way to evaluate that this system is kind of working?
The easiest way.
Yeah. Like, do I use something like crowdsourcing, or like is there?
I think crowdsourcing could be one. Depends on also like how big is your team. Definitely, and that's like a major criteria, because ultimately, I was actually going to recommend a book, like Human in the Loop, because ultimately everything needs to go through a human, because I think the systems aren't really well equipped enough. Although there are strategies in which it involves prompting to evaluate the responses as well. So, for example, what I found was preparing maybe 30 questions and the sample responses based on the different kind of domains my chatbot is going to be used for. And all of these 30 questions would have one response. So what I could use is, I mean, as part of like more black and white matrix, the one that we prefer in the search systems like Precision Recall, NECG, MRR, so on and so forth, we would use vector similarity, like how much of my response was similar. Again, we are using semantic similarity here. We can again use vectors for that. So based on these 30 questions and 30 questions, evaluated against my RAG pipeline, and also they have the fixed responses already given into the table. How much of my response was similar to the response that I had said is the good response to this question. So again, we're still playing in the world of vectors.
Yeah, so there's the book you mentioned, Human in the Loop. It's a book from Manning, right?
Yeah, Manning, yes.
It's by Robert Monarch.
Correct. That's the one, yes.
Yeah, like I know about this book. And in DataTalks.Club, we have a thing called Book of the Week, where we invite authors to answer questions about the book.
Oh, wow.
Back then, Robert was busy working on the book, and he told me, yeah, let's get in touch later when the book is published. So apparently it has been published in July 2021. Quite some time ago.
Indeed. I was surprised. I was surprised when you said like he was working on the book. Okay, interesting.
Yeah, it was some time ago, yeah. So the community is like 3 years old.
Right.
Yeah, maybe it's time we talked with Robert. Maybe we can invite him to the podcast too.
Sounds like a fab idea.
Yeah.
And as rest of the podcast, I would definitely be on that one too. I would love to interact with him, because I find this book is like really amazing.
Okay. Yeah, so I made in a note to contact. But so I noticed that we have a question. The question is from Taras. So Taras is asking, is there any application of vector databases for machine learning? For instance, could it be used for making training of deep learning models faster? Or maybe there are some other applications of vector databases for machine learning.
That's actually a good question, I would say, because there's a feature. So I'm not sure how much of the space do you follow, but then recommendation is one thing that is a machine learning feature. And vector databases are like pretty amazing at addressing this, because again, we can use vectors in many different forms. We can use personas as a vector, and we could have the recommendation and have the personas and maybe based on the persona similarity of two people, we could have recommendation of the products. One of the other things that I saw is something that has been a recent kind of change, is that recommendation itself has a very changed meaning, as you were discussing about the changes. So now people are more kind of driven towards recommendation in a certain session, instead of storing the recommendations for each user, because a user could have several queries, 100 queries. So these recommendations have to be updated per session. And this is where vector database, and especially Qdrant, because I know this is supposed to be launched today or maybe in this week, is going to be one of the changes where we can build the recommendations based on every click that the person provides. And this is where vector database is going to be amazing, because these recommendations would be updated on fly based on every single click of the user.
That's really cool.
Yeah.
So I know like there's this classical approach to recommender systems, which is collaborative filtering.
Mhm.
So you take like all the users, you take all the items. So then you have this large matrix and you somehow like reduce the dimensionality of this. So at the end, what you have is like vectors for users, vectors for items. And then what you can do is just take all the items, all the vector for items, put them in a vector database, right? And when the user comes, or maybe you can pre-generate it, like basically for each user, you query the vector database, right? And then you get like the recommenders.
Right.
And then like
So,
there are many different problems with this approach, right? Because like
right. So re-ranking was another way in which vector databases again could be of help. So
what you mentioned is, so with collaborative filtering, so we would need to like redo the whole thing, right? And then the vectors we do from another training will be super different from the first training. And what you mentioned right now with clicks updating for sessions, like there are other techniques you can use that.
And it doesn't need any fine tuning. It doesn't need, so in case of like the cross encoder method as well for the re-ranking, I think you can completely skip that part and you can do it on the fly. So that actually reminds me of something really funky from 2016. Like the first time when the recommendation was introduced by Amazon. And I remember that there was a talk given by someone from Amazon who apparently bought a toilet seat, and he wrote to Amazon that, I had one toilet in my apartment. I bought one toilet seat. I don't need any more toilet seat. Just get this toilet seat recommendation out of my feeds. I don't need any more toilet seats. So I think the recommendations have also, come a long way from then. And I think the session-based, so for example, like TikTok users or any video platform users, like the recommendations are basically built on the fly is what is like kind of a next thing.
So which means, okay, so I bought my toilet seat and now I'm searching for something else.
Yep.
And then you can see that in my last sessions, I was checking, I don't know, pencils, right?
Yep.
And then you see, okay, like I have checked this pencil, that pencil. So this person is probably interested in pencils. Let's just show him a ton of pencils, right? Instead of toilet seat that I bought earlier, right?
Right. And that's very, I would say, like the sensible approach.
I'm searching for pencils right now, right? So that's what I'm focused right now. So it makes sense to
the context actually becomes the thing.
Yeah, makes sense.
Yeah.
But probably Amazon is doing something smarter, so they can know now things that are currently ordered, things that you order and never want to order again, like the toilet seat, right? So for example, like I like peanut butter, and I use Amazon for ordering that, and like they know that I might run out of peanut butter, so this, how about you buy it again? So they know when I run out of peanut butter, so then they kind of push this recommendation to my face. And when I just bought peanut butter, I don't see this recommendation. There's something else. And so they are very smart. So they know when I will need. So they probably have like a ton of different vector databases.
For sure. Oh, there are like a lot of different permutation combination, which is why I love e-commerce, because it's like so happening all the time. There's something coming into the existence. There's always a new user need, and that really pumps me about the field.
So if somebody wants to learn about classic information retrieval before like all these vectors, would you say this introduction to information retrieval is a good starting point, or there's something else? I
would say so, and I would highly recommend you reading a Relevant Search book as well. Yeah, that's definitely like one thing, and I think we have tons of blogs and I think whatnot.
Relevant Search. The Relevant Search covers. Is it about Elasticsearch or Solr? I don't remember. It's Elasticsearch, right?
I think it's very search engine agnostic in terms of the book, which is why I recommend it. So you can use, and there would be examples that come along with the book. Hopefully also Solr driven as well, mostly Elasticsearch. But I think the idea is to communicate the thought process and the analogy of the concepts. And I think that are delivered pretty well with the relevancy guy himself. You know who the relevancy guy is?
Duke, right?
Doug Turnbull, yeah.
Yeah. He gave a talk at DataTalks.Club at some point. So yeah, it was very nice to have him actually. Yeah. So then when it comes to more recent developments, like all this RAG stuff, is there good resource? So you mentioned you're working on a blog post.
Yep.
But is there something else you would recommend to check if somebody wants to learn more about this stuff?
I think from the evaluation point of view, or
Just
from
in
the
general,
implementation?
also from about RAGs.
Well, I think LangChain has been the site itself is like plenty of different things that they offer, like different ways in which RAG could be achieved with different search engines. So that's definitely, I would recommend reading about it. Plus, there's a new resource where I would be contributing my blog on Vector Hub. So that's like another place that I can recommend you checking out. Great content. We're working on a lot more interesting content as well. And what else? I think nothing else comes to my mind.
Probably already is like relevant search, LangChain documentation, then Vector Hub. So please send us the links.
I'll do that.
Like whenever you publish something new, we're also interested to know that. And
Sure.
I assume every time you publish something, you also make a post about that on LinkedIn, right? So we can follow you there.
I try to do that.
Up to date.
Yeah.
Yes. So please make a post when we publish that in the evaluation article. And with that, I think, yeah, that's all we have time for today. So Atita, thanks a lot for joining us today.
Yeah,
And
it was a pleasure.
now I know that your name is a palindrome. It never occurred to me to actually think about that. I'm wondering how many guests.
Mission accomplished.
How many guests we had in the past with a palindrome name? I don't think we had any. I'll check that.
Okay.
Good that we had the first guest with a palindrome, first and last name. And yeah, I think that's all for today. So thanks everyone for joining us today. And thanks Atita for sharing your experience with us.
Thank you so much for having me. And thank you everyone who's been listening today. Thanks. Have a nice day.